Hi, this is short tutorial about question 3.2, and I show in this tutorial how to solve this problem using Stata. So how to solve the problem using simulation. So what's the problem? So problem is that we have some college, and we have students can take either math class or might not take it, and the same student can take science class or may not take it. So we know that probability or the fraction of students who take math class is 50%, probability of students who take science class is 30%, and those two events are independent, and we want to find out three different probabilities. Probability that student takes both classes at the same time, the probability that student take either class, math or science, and probability that student takes a math class conditional that he takes science class. Let's open up the Stata and let's do some programming and see how we can simulate this problem and find out the solutions. Okay, now on the screen you should be able to see the Stata program. So we want to simulate, as a first step, we need to simulate the random numbers representing whether student takes math class or the science class or both, or none of them. So first of all, what we do is we reserve the place for the simulation. So we set aside the space for 1 million observations, and we set the seed for the random number. So by setting those seeds, it will be, the program will be immune. So the program will get the same results no matter what machine you run. But if you don't specify the seed, then the answers across different simulations by different computers would be different, okay? Because random numbers would be, set of random numbers would be different. Okay, let's set aside the set of observation and set aside the seed, okay? And next step I want to generate would be a random variable g, okay? So what I say, I generate g equal 0, which basically indicates that student does not take math class, and we replace it by 1 with probability 50%. So that means what? With probability 50%, g will show up 50% of time. So g will be 1 and 0 with equal probabilities. Okay, so let's run these two lines. So and you see here we have 1 million observations, and around 500,000 times student takes math class, which is confirmation that it's 50%. So half students take math class and half does not, okay? So same way we want to generate now random variable h. So we say generate h equals 0 and replace h equal 1 with and that should happen with probability 30%. Okay, so I will replace here. So I will get now, I will run this program, and if you see here, we get about h was equal to 1, about 300,000 times out of millions. So the fraction or the proportion of students who take the science class is 30%. All right, next step, we want to find out what's the probability that student takes both classes. So I will generate new random variable, which I call g and h, and that would be what? It would be g times h. Okay, so now what I did basically is g and h will be either two possible values, right? Because g and h have two possible values, 0 and 1s. 0 and 1 product combination, we have only two possible outcomes. Why? Because 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, and 1 times 1 is 1. So I'm getting g and h, the random variable g and h would be 1 only and only if both g and h are 1s. Okay, otherwise I get 0, right? So this way I can see now, and I will now summarize. Okay, I will summarize now, or I need to tabulate. Summarize gives me the moments. I need frequency table, right? So I will tabulate G and H, and now I'm seeing here G and H is 1 50% of times. So probability that G and H occurs at the same time is 50%, which means what? They occur at the same time means that student takes both math and science class simultaneously. Okay, so that concludes A. Now I want to generate a random variable G and H, G or H. So I will type now G or H, and I will say it is what I want. So let's think for a second. So I want either G occur or H occur, right? So which means what? If I say G plus H, then what are my possible values? I can get 0, 1, or 2, right? So 0 will happen that if student takes neither math class nor the science class, right? So in order G plus H to be 0, both of them should be 0. So that means what? Student takes neither math class nor the science class, right? So if this value is 1, that means that student takes either, right? So it takes either. So and if it's 2, then it means that it takes both classes. Okay, so now instead of this, I think it's not a good idea. So let's think for a second. So I will generate G or H equals 0, and then I will replace, I will modify G or H to be 1 if G plus H is more equal to 1. Let's think for a second. So what does it mean that G plus H is more equal than 1? So we said G takes values 0 and 1, and H takes values of 0 and 1. G plus H takes values 0, 1, and 2, and only desired outcome which we are looking for is either 1 or 2, right? Because if it takes value 1, G plus H takes value 1, that means student takes either math class or the science class, or but not both. Okay, but so those are two blue rectangles. So G plus H would be 1. If you remember my presentation from the PowerPoint, so we had 3 rectangles, right, in the square. 2 blue and the 1 in the left-hand side corner, red one. So red one was both classes we are taking. So if a student takes both classes, then G plus H would be 2. But that's also desired outcome, right? We are looking those 3 rectangles. So that basically should do the job, okay? So I will say G or H, and now I will tabulate G or H, okay? So I will tabulate, tabulate G or H, and see here G or H takes value 1 with probability 65. So that basically gives us the solution by simulation. And finally, we want to simulate and get the probability that the student takes math class conditional that the student takes science class, right? So what I do now is the following. So I will tabulate. Okay, so let me see. I will tabulate G and H. Let's see what happens here. Okay, tabulate is mistake. Tabulate G and H. Let's see what comes out here, right? So now this is the cross tabulation. So we have two variables, G and H, taking those two respective, outcomes, 0 or 1 or 0 and 1. And now we are looking now, we know that student takes science class, so we are on this right-hand side vertical column, okay? So this column, all right, let me grab, I can write on the screen, so let me grab here the marker. So we are on this rectangle, okay? So now we want, respectively, how many ones we have in this rectangle. So G is in this rectangle 1 and 0, and 1 is how many times? 150,000, 230, okay? And G is 0, how many times? That you see here, the ABBA one, okay? So this one is conditional, G equals 0, conditional that H is 1. So this is 150,472. So that basically indicates that, if H is 1, G taking values 0 and 1 are almost the same. So it's 50%. And the same is true even if H takes value 0, okay? So if you are in this rectangle, those two numbers are still equal, okay? So that means what? Probability of G given H, no matter what is value of H, either 1 or 0, it would be 0.5. Or in other words, this is unconditional probability of a student taking science class. Okay, that's basically, idea behind independence of two events. I think that concludes question 3.2. I hope this was helpful. Thank you very much for your attention.